think we stopped here. I think. Um, now, what's this one? Just make it a little bit bigger. So for this one, they're asking how this, the original one, right? This guy right here, turn into this. Obviously, it's, well, not obviously, but let's start with what I asked you before. If you look at the order in which these guys are seated, if we go clockwise, it's M-A-T-H. If you look at this seating arrangement from the second figure, it's M-A-T-H. So the order hasn't changed, the orientation hasn't changed. So that means that there's not a reflection that was done here. It looks like a rotation, right? A 180-degree rotation, but if you think about it, it's not a rotation right off the bat, because if you, let's pick this T here. T, it's 1, 2, 3, 4, 4 and 2. If this T was rotated 180 degrees, first of all, if you use that little trick, we switch places once, switch places again, and it would be the same two numbers, but both of them would be negative because T lands in quadrant 3. -4 and -2, it's 1, 2, 3, 4, 1, 2. So T prime would be over here. So obviously it's not a straight up rotation because that wouldn't work. So the other thing, right, the one thing you have to do is look at point HH. HH is over there. For H prime or double prime to end over there after a rotation of 180 degrees, it should have started over here. So what we're going to do, we're going to move this piece over here from there, from the origin where H is right now, to -1 and we're going to move the rest. So we're going to move one right, one down, one right, one down, one right, one down, and point A is right over here. So if you move that shape, so translate it, so let's translate that shape, x plus 1 and then y minus 1, you're going to get this shape over here, right, this shape right here. Now, if you notice, point H is in quadrant 1, point M, point A, and point T, they're all in point H is in quadrant 4, point M, A, and T are all in quadrant 1. If this is rotated 180 degrees, MAT will land in quadrant 3, which is what you see right now. And H, who is in quadrant 4, would land in quadrant 2, which is what you see there. So the two transformations that we had to do was, one, a translation of moving the original shape a little bit to the right, and one right, one down, and then rotate it 180 degrees. Okay. Again, let's look at the orientation first and see if there's a reflection involved. So if you look at this, this is the original one. It's the order goes D, R, A, E. If you look at the bottom one, the order changes. It's D, who's followed by E, who then is followed by A, who then is followed by R, right? And then write the primes. So there is a reflection involved because the orientation changed. Let's figure this out. Notice that look at A and E here. Look at A and E. They're on the left side, right? And right now, A and E, A prime and E prime on the left side, but A and E here are on the right side. So what if we did a reflection over the y-axis? So let me put a little line over here. That's my line of reflection. What if I reflected this to the other side? Well, D is going to stay where it is. R is going to be 1, 2, 3, 1, 2, 3, R prime. A is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And E is going to be same thing, 5 units away. So if you flip this over the y-axis, and then, so the first one will be a reflection over the y-axis, That's number one. And then number two, notice that now I can take this guy over here, right? And I can move him a little bit down, sorry, a little bit to the right. So here it was. I'm going to move him to the right and some units down, and look how it ends up. So the second part of this would be a translation, all right, to the right and down. All right, I'm not going to count it, but that's what we would do. All right, so that one actually was pretty simple. Okay, I'm going to ask you to look at the order again. So let's look at A. So again, A, the next person sitting next to A would be D, who's followed by C, who's followed by B, if I went clockwise. Right? Let's do the same thing at the bottom. A prime is seated, and then the next person would be a D prime, and the next person would be a C prime, and the next person would be a B prime. Notice that the order in which they're seated are the same, so no reflection involved here. So how do we do this without a reflection? Well, first of all, this right here, it's not a reflection. Because if that was a reflection, let's look at point A. Point A is 2 units away from the line of reflection. Point A prime would have been over here. Point B prime would have been over here. Point D prime would have been over here. And C prime would have been over here. All right, that's what it would look like in a reflection. Sorry, reflection over the y-axis, but x-axis. But that's not it. So we know it's not a reflection. Right? So I think it was Leah who said this in 802. What if we move this shape over here? Let me draw it. Right, as it is. Let me take that shape. And move it. And I'm going to move it the same distance away. So right now, A, right? A is 1, 2, 3, 4 units away. So I'm going to move this trapezoid 2 units to the top. 1, 2. Now if you think, and then let me label the points. So this would be A prime. This would be B prime. This would be C prime. This would be D prime. Now, how can we take this shape, the blue one that I just did, to look like that? Well, it's not a reflection, but again, because of reflection, remember, if this was a reflection, A double prime, right now change colors, would be 1, 2, 3, 4, 1, 2, 3. This would be A double prime. And this would be B double prime. So you notice that the letters don't match. So we know it's not a reflection. So the only other choice, well, I mean, think of an arrow. It's pointing that way right now. 180 degrees rotation, it would be pointing that pointing down. So this is a 180 degree rotation. So it works because look, points C prime and B prime, these 2 points are in quadrant 1. After a 180 degree rotation, where would they land? They would land in quadrant 3. And so far, the same thing applies to A prime and D prime. They are currently quadrant 2. After 180 degree rotation, they would land in quadrant 4. So this works out nicely. And just to go over one more, let me prove it by picking one of the points. So let's try point, and let's get it right. Let's try this point right here, B. B is 1, 2, 3, and 4 up. So after 100, it's in quadrant 1. So after 180 degree rotation, it'd be in quadrant 3. And the points would be 3 and 4, right? Because you switch once and then you switch back. But in quadrant 3, everybody's negative. Is that where B is? Look, 1, 2, 3, and then 1, 2, 3, 4. B is in negative 3, negative 4. So this works out. So this is a translation up 2 units, or was it 2? Yeah, up 2 units. And then a rotation of 180 degrees. Describe a series, okay, so again, and one key here, it says rigid motion, so right off the bat, if you remember, it was a couple of weeks ago, but dilations is out, right, because it's not a rigid motion. So no dilations for sure. Let's look at the order of the letters. Look, this is the original triangle. So this one is A. Let's go clockwise. A, C, B. And here, let's look at the order in which these people are seated. It's A double prime, B double prime, C double prime. Notice that B and C, they switch places. So there was a reflection involved. Actually, this is not that bad. Let me just trace this. So, we know there's a reflection involved, right? I'm going to take this original triangle and I'm going to lower it by 1, 2. There, I'm going to bring it down there. So this would be C prime, this would be B prime, and this would be A prime. Now, so first one, step 1, translate 2 down. And then step 2, now I can do a reflection, and you'll notice that everybody is equally distanced from the line of reflection. We're going to write reflect over y-axis. And let's see if that works. So let's look at point C. Point C is 1 unit, 2 units away from the line of reflection. Point C double prime is also 1 unit, 2 units from the line of reflection, so that works. Look at point A. It's 1, 2, 3, 4. Point A prime, 1, 2, 3, 4, right? Also 4 units away from the line of reflection, so obviously this works. So what are the 2 transformations that happen here? The translation down of 2 units and a reflection over the y-axis. All right. Notice that these 2 sizes, these 2 rectangles are congruent. They're exactly the same size. Let's look at the order. H, so here H is seated next to J, who's seated next to K, who's seated next to L. This one, let's start with H. H prime is seated next to L prime, who's seated next to K prime, who's seated next to J prime. Are they the same order? No. There was a little switch here. Right, you can tell there's a switch. So there's a reflection involved here. Okay, so I'm going to reflect this. So, now we have got to make this rectangle. Trace it. All right, first of all, I got to take this rectangle, and we got to take him and rotate him. All right, so we got to rotate this guy here, and as well, we got to move him over. Right? So the first thing we're going to do is see if a rotation. So let me take a point K here. Let me take point K. Point K is -4, 2. So if we rotate this guy 90 degrees clockwise, point K prime, right, this new location, well, we're going to switch this order once. So 4 and 2 switch sides once, and then in quadrant 1 is 2, 4, so let me put 2 over 4, and this will be point K. K prime, sorry. And then let me pick point L. Point L is -8 and 2. If you switch them, it becomes 2 and 8, and then point L would be L right here. We'll call that. So you notice that it's working. So this. Now, so the first one is a rotation, and now this, is this a reflection? Well, let's look. Is point K 2 units away from the line of reflection? Yes. Is point K prime 2 units away from the line of reflection? Is point L 4 units away from the line of, sorry, 8 units away from the line of reflection? So, sorry, it's counting by 2s. And then point L prime, is it 8 units away also? So notice that this is J prime, and this would be H. Right, so that works. So it's a 90 degree clockwise rotation and a reflection over the x-axis. Let me see this one. Describe it right. Something from F to G. So again, trace it, or how do we get this to look like G? What can we do to it? Can we rotate this? Well, what if I reflect this? Right, so let's reflect that now. So let me take, I'm gonna give it letter A, B, C. I reflect A to this side. It's going to be 1, 2, 3 units. So 1, 2, 3. This is A prime. B would be over here. And C would be right here. So there's my triangle. So first, a reflection over the y-axis. Sorry, x-axis. That's number one. And number two, can I then reflect this that way? Reflect over the x-axis. Let's see if it works. So that's A prime, A double prime should be 2 units away from the line of reflection. And let me give you the line of reflection, which I didn't draw. All right, so A prime, which is this guy right here, that works. B prime, which is this guy right here, that works. And then C prime is this guy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Look, it works. So it's a reflection over the y-axis first, right? Because that's what we did. We went from here to here. And then a reflection over the x-axis. Okay. Okay. Oh my God, what can we do here? From A to B, okay? So what if I reflect now? All right, notice that I'll put an arrow like this, A, and point it up. If I did a 180-degree rotation, that would be pointing this way. Okay, so let me do that. Let's see if that works. So let me rotate this 180 degrees. So I'm going to call this, let me work with some point. This is 4 and 1, right? I'm going to call it A, call it B, C, and D. If I rotate point A 4 and 1, I'm going to get A prime, which is still going to be 4 1, but everybody's going to be negative. Negative 4, negative 1. So this is A prime right here. If I rotate B, which currently is 9 and 2, it would still be B, so we're going to call it, but everybody's going to be negative. Negative 9 and negative 2. This would be B prime. And then if I rotate C, which is 9 and 5, it will still be 9 and 5, but everybody's negative. Negative 9, negative 5. And point D is 2 and 5, which rotated would be D prime, negative 2, negative 5. So negative 2, negative 5. So notice there's a little bit of work to be done, right? It's not like just looking at it and guessing. So you might have to do some work. So if I rotate this A, right, which is the original, 180 degrees as it is, it lands right here. Right, so now, and I'm going to erase this because I'm going to shift it, translate it, I mean. So I rotate it, so first one, I'm going to run 180 degree rotation. That lands from there, it went to this. Now I'm saying that, hey, the easy part would be to, what's the second thing that we can do? Is to move it to the right and then move it up. And it lands. Oh, ha ha ha. Okay, ladies and gentlemen, I was fooled for this question. Big time. Actually, let me show you how much of a fool I was fooled. And I only noticed it after I tried to translate it. So I did a rotation. But I don't know if anybody noticed that this particular trapezoid, right, this line is flat, and this line is flat, right? Two horizontal lines. Now, if you look at the one that I have, but that they have, this line matches this line. This line sort of matches this line. This line matches this bottom line, but guess what? This line does not match this line. So how can A transform to B? The answer is it can not. Why? Because they're not even congruent to begin with. So all this for nothing. I'll erase everything. Figure A, this figure A, will never transform through reflection, rotation, dilation, and whatever, I'm missing ones, and translation, rotation, reflection, dilation, any of the four will never turn in figure B, ever. So describe a sequence of transformation. There isn't one. Ooh. Wow. That wasn't nice. 8. So we're going from this is the original, right? This guy here, the original. I'm going to say this is the original. And it's going from this to that. All right, so let's look at their seating arrangements first. So we go from A, C, B. We go clockwise, right? And then over here, it's A prime who's sitting next to B prime, who's then sitting next to it. So you notice that this order has changed. So there's a reflection involved here. Okay, this is not that bad. So this is it's pretty easy actually. So if you look at it, all you have to do is take that guy and move it. So let's see, we're going to move it one up. That's it. So if you move it exactly one up, oh gee, I'm a little bit disappointed. This is A prime, B prime, C prime. And we reflect this. So the first move is a translation up. Up 1. And then 2 would be a reflection. And we know there was a reflection because the orientation changed. So reflection over the y-axis. So, and again, just to confirm, look, these two A's are exactly 2 units away from the line of reflection, which is this guy right here, which I can't draw, right? And then notice that everything else also moves. C, this, and then B prime, well, that should be B double prime, and this B prime exactly the same distance away from the line of reflection. Okay. So I would always check for orientation, right? I mean, dilation is the obvious one. This one, obviously a dilation, right? Obviously it's a dilation. But let's see how we can. So if you look at the corresponding sides, right? Look at this side, side AB, right? And this is, again, this is the original one. So, and this is A prime, B prime, right? If you look at, so side AB is just 2 units, sorry, because we're going by 2s. And side A prime, B prime is from 4 to 8, so that's 4. Remember how I find scale factor? Right, just take the new measurement, which is 4, over the old, which is 2. And this triangle grew by a scale factor of 2. So we know that we can say a scale factor of 2. So dilation, dilation happened? No. So we can say, we can, what the first thing we're going to do, ACP, okay. And also notice that the orientation had changed. So if you go clockwise, it's A, who then is C, and then who's B. And then if you look at the bottom triangle, it's A prime, who then is B prime, and then C prime. Notice that this order changed, so there was a reflection. So what we're going to do first is we can reflect it, right? We can reflect it, so we can reflect it first. reflect over the x-axis, and then 2, dilate by 2. Dilation by a factor of 2. So if you think about it, if you reflect this over, you're going to get A over here. Sorry, B over here. You're going to get A over here. And you're going to get C right here. Right? And you're going to get this triangle here. Sorry. Yeah, so that's 2 units. Sorry, I can't see. That's there. A is going to be and C is going to be so. Right, so it's going to be like this. Right, and then you're going to dilate it, and the distance that each point it is to the origin. So that's what's called that A prime, B prime, C prime. It's going to double. So notice that A from the origin is 1 over and 1 up. Sorry, B. Make that a little better. Sorry. So if you reflect that first, you get this. Okay. This is going to be B prime. Think of this as A prime. And I don't know why they write 1 prime. It should have been double prime. So that's the figure of the triangle after reflection. And then if you look at the distance B it is to the origin, is 2 to the right and 2 up. So B prime is actually 4 to the right and 4 up. Notice that the distance to the origin has doubled. So it's a reflection over the x-axis and a dilation by a factor of 2. You need to confirm with the numbers, right? You know, if you have numbers, like pick a number on the shape, rotate it, reflect it, see if it matches on the other side. That's what I would do. Besides, I'm not too crazy about questions that don't have primes. That just breaks me a little bit. So I wish they did that instead of RSTU and ML and K. I don't know why they do that. Notice that these shapes, right, looks like they're flipped, right, like a reflection should be, but they don't match exactly what they are. So this one's pretty easy. The first thing maybe we can do is shift this over, take that trapezoid and translate it 1 over, just 1 over. And if you translate that 1 over, and then we change colors here and get these and focus, and you focus on these points, this one, this one, this one, and this one, and you reflect that over this line, notice that they will match because this point right here matches this point. It's 2 units away. This point matches this one, which is 2 units away from the line reflection. This one is 4 units. Point R is 4 units away from the line reflection. Point N is also 4 units away from the line reflection. And this point right here, it doesn't have a name, is also 4 units away. So this was a translation. And we can just write x minus 1. Right, the y stay the same, and then a reflection over x-axis. Not as bad. There's some work to do, but not really that bad.